The position of a particle moving on the x-axis is modeled by the equation S of t equals 36t minus 12t squared plus t cubed. T is greater than or equal to 0. And I have to find, first I'm going to find A. So I have to find the velocity of S of t. So S derivative of t equals velocity equals 3t squared minus 24t plus 36. So that's A. I found the velocity. And then what is the velocity after 2 seconds? So I plug in 2 for velocity. So v of 2 equals 3 times 2 squared minus 24 times 2 plus 36, which equals 0 inches per second. So v of 2 equals 0. And then part C, when it's a particle at rest. So the particle is at rest when t equals 0. So C, I have my equation equals 0, my velocity equation equals 0. So I have 0 equals 3t squared minus 24t plus 36. And then I can take out a 3 and get 3 times t minus 2 times t minus 6. And I found out that t equals 2, which I got from here also. And I found that t equals 6. So when t equals 6 and t equals 2, velocity is 0. So now I have C. And D, when is the particle moving forward or to the right? So part D. Alright, so now I have to find out when the particle is moving to the right. So that's when velocity is greater than 0. So I plug in points that are between 0 and 2 to find out when velocity is greater than 0. See if velocity is greater than 0 or if it's negative. So I plug in v of 1, and v of 1 equals 15, so velocity is positive. So that means it's moving forward or to the right. And then I plug in the point between 2 and 6, and I plug in v of 4 equals negative 12. So velocity is less than 0. So that means the velocity is not moving forward. So it's not moving forward. And then I plug in a number greater than 6. So I plug in v of 7 equals 15. So it's positive again. So that means when t is greater than 0 but less than 2, and when t is greater than 6, the particle is moving forward. Okay, and now I have part E. Find the total distance traveled in the first 10 seconds. So part E, I have absolute value of f of 2 minus f of 0 plus absolute value of f of 6 minus f of 2 plus the absolute value of f of 10 minus f of 6. So the total distance after 10 seconds would be 224 inches. Part G, find the acceleration of the particle at time t and after 2 seconds. So acceleration is the derivative of the velocity. So acceleration equals 6t minus 24, and a of 2 equals 6 times 2 minus 24, which equals negative 12 inches squared, negative 12 inches per second. And then part I was when is the particle speeding up or when is it slowing down? And there we go. When is the particle speeding up? When is it slowing down? And I did it graphically. When velocity is positive but going down, or velocity is negative and going up, that's when it's slowing down. And when velocity is positive and going up, that's when it's speeding up. And when velocity is negative and going down, that's when it's speeding up. So I have a graph, and on the graph you can see that from 0 to 2 the graph is slowing down because the velocity is positive and going down. And from 2 to 4 I found the minimum. The minimum is here at 4, and that's when the particle starts slowing back down because from 2 to 4 it's speeding up because the velocity is negative and going down, and at 4 it's negative and going up again. So from 4 to 6, negative and going up means it's slowing down. And then from 6 on to infinity, it's going positive and speeding up again. So I did it graphically, and that's what I got.